Okay, I might have lied a little bit. You need to find a blank area to write out another example, because I want to do one more example with that, with the triangle law. So if you use the back of the note or pull out another piece of paper, I want to do this final example so you get a better feel for how to do it. So we're determining the resultant. So that means what I want to do is the resultant is going to equal vector u plus vector v. Okay, so here is a case where I drew the vectors for you. So this is kind of what we call the worst case scenario. So what you want to do is you want to draw the vectors head to tail. So I'm going to take the first vector here, u. And what I'm going to do is I'm going to keep that 50 degrees for a second. 50 degrees to the horizontal. Okay, and I also have to provide some magnitudes here. So let's go magnitude 6, and the u vector is equal to magnitude, let's go 4. Okay, so that vector there has length 4. Rewriting the other vector, so I'll clone it. And again, I need to draw in that angle that's given, so it's from the tail. So that's 20 degrees. All right. All right, so here we go. So the resultant will look like this. So it's not 50 degrees from the horizontal. The resultant is down a little bit. All right. So where do we start with this? Where do we start with this particular question? The answer is you got to use your geometry from grade 9. And I know this hurts. So from geometry from grade 9, we take that 50 degrees because it's going to help us out. If we create a Z pattern, okay, our good old Z pattern from grade 9, we will see that the angle down here is also 50 degrees, okay, from the Z pattern. You got to ignore the resultant. We're just looking at the green line and this green line are parallel. All right, so that's 50 degrees. What that allows us to know is this angle in here, 180 degrees for a straight line, minus 50, minus 20, so that's minus 170, so that angle is 110 degrees. Okay, that's the hard part with the triangle law. It's from now on, it's straight downhill. Magnitude of the resultant equals magnitude of u squared plus magnitude of v squared minus 2 magnitude of u magnitude of v cos a. So that's off the formula sheet. Now you plug in your numbers. 4 squared plus 6 squared minus 2 times 4 times 6 cos 110. Okay, so literally that drawing the picture is always the hardest part. Ask anyone that took the physics course, anyone that's doing the vectors. Once you have the picture, it's just a matter of doing your calculations. So times 110 cos. So I get square root of 68.4. Some of you might be jumping straight to final answer, which is perfectly fine. So you should get 8.3. So it's 8.3 units are resultant. Now, I told you that the angle equation that I gave you in the previous one will give you your final answer almost all the time. And this is the catch. So we are going to use it to find this angle. It's not the green angle. It's less than 50 degrees. So we need to find that angle anyway. So we're looking for theta. So that formula still works. Sine inverse of magnitude of V sine A over magnitude of resultant. That doesn't change. So I'm not lying to you. So the magnitude of V was 6 sine 110 over the magnitude of the resultant, which we just got to be 8.3. Solving that, we will now have an angle to calculate. 6 times 110 sine divided by 8.3 inverse sine, 43 degrees to keep life easy for us. So the angle inside the triangle is 43 degrees. So that's 43 degrees. So if I want to give a direction, so we're at the therefore statement here. We're at the therefore statement. So therefore, resultant is 8.3 units. It's the direction that's the challenge. So if the green line represents a horizontal line and it's 50 degrees, that vector's 50 away. The red one is 47 away from vector u. What's the difference up here? So that difference would be 50 degrees. that little angle in there is going to be the 50 degrees. Take away what we just found, 47, and we find it's 3 degrees below the x-axis, if you want to think of that, or the east. So that means if you face east, and then you rotate 3 degrees toward the south, you are facing in the direction of the resultant. Okay, so the picture is very important. Yes, it is challenging with the geometric. That's why we have a bunch of practice questions lined up. But like I said, if you did take the physics course, this is exactly what we did in the physics course. For those that did not take physics, this will be a little bit more of a challenge. But like I said, once you have the picture, you're fine with the algebra. You can do the algebra. Last example. This is the easy one. When you have a picture, you actually have a grid. So you will be using graph paper for some of the questions. So here we go. We want to find the resultant of 3u minus 2v plus 5w. So what do? On the graph paper and on your grid there, I'm going to take the u vector. I'm going to draw it over here. And where am I going to draw it? Actually, start down here somewhere. Give yourself a little bit of space down below. So that's 1u. Okay. We now have to do 3 u's. So they'll be stacked up. So 1, 2, 3. Now, do you have to draw the individual vectors? Absolutely not. You can simply draw a vector that extends from the start to the end and just count your squares. Okay. Now, when I'm looking at this, I don't think we're going to fit on the page. So I'm going to edit this a little bit to help you out so it fits on the page. Let's go with the negative 2v is fine. Let's just scratch out the 5 on the w. Let's just add w. That way you're not going to get really angry at me. So now we're doing the negative 2v. What does negative do to a vector if it's negative 2? And see everyone's hands up, which is great. It changes its direction. So instead of facing down, 2 units, it's actually going to face up 2 units. So if I can have the end of that. So there is negative v. That's 1 negative v. Clone it again. Okay. And now we have our negative 2v. And again, you can just draw it from start to finish. Now we're going to add a w vector. So we clone that. You're just counting squares when you do it. We end up right there. So there's our w vector. So where did we start? We started right here. The resultant will be going from start to finish. All right. And you can see that that's quite easy to do. The resultant doesn't change angle, it doesn't change direction. So that kind of is a little bit on the frustrating side for me because it's not going to do what I want. But the resultant is, just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15 is 16 units. Don't have to calculate an angle, and that's why it's a little bit frustrating. Straight east. Okay? So let's play a what-if game. And you wouldn't hurt copying this down. What happens if that W was facing in the other direction, for argument's sake? So you probably don't want to change your note. So let's say the W is up here. Okay? So let's say W was there for argument's sake. Don't change your note. You can just follow along right now. What's the difference? The new resultant would be right here. All right? How do you calculate magnitude? Well, you can't count squares because it's on an angle. So the magnitude of the resultant would just be the hypotenuse of a right angle triangle. So for these questions, you can create a right angle triangle and you can count squares. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here, to find the magnitude, it comes from the Pythagorean theorem. A squared plus b squared equals c squared. So the formula you're going to put on your cheat sheet is my resultant is equal to the square root of the x component squared. So I got to put x squared plus y squared. So there is the formula that you want on your cheat sheet. Okay. This is your x, this is your y. All right, that's where that comes from. How do you calculate the angle? The nice thing with this method is that it always forms a right angle triangle. It will always form a right angle triangle for us. So if that's the case, to calculate the angle, theta will equal, you're going to have your opposite side and your adjacent. It's always going to be tan inverse of the y value over the x value. So those two formulas will calculate if you need to draw the picture out on a grid. Okay, so the previous examples, I'll just slide back for a second. These two examples here, this is the process when you don't have a grid and you're not going to measure it out. Okay, so there's some questions like that that you have to do. Then there are questions where you can use the grid and you can draw the picture. If you can draw the picture, you can then determine the right angle triangle. And if you have the right angle triangle, these formulas work for you all the time. All right, so the next day or so when you're working on this, for people that haven't done the physics, again, it's going to be new material. Don't get frustrated, work your way through. If you've already taken the grade 11 physics, this is exactly the same method that I used when I was teaching it. So that should move you through, or any physics teacher that's teaching the grade 11 course with vectors, should be no problem. All right, so if you have any questions, please ask and I will clarify.